Hello, calculus fans! We want to introduce some new terminology. So we're going to say that a sequence a sub n is bounded above if there is a number m such that a sub n is less than or equal to m for all n bigger than or equal to 1. So basically, the terms of the sequence do not go above a particular number. And similarly, we can say that a sequence is bounded below if there is a number little m such that m is less than or equal to a sub n for all n. And that's just saying that there's some number where you don't go below that. Now, if the sequence is bounded above and bounded below, then we're just going to say that the sequence is bounded. So bounded means it doesn't go above something, it doesn't go below something. So for instance, the sequence a sub n equals n squared, it's bounded below because you never go below 0, but it's not bounded above because the terms of the sequence increase indefinitely. The sequence a sub n equals 2n squared over n squared plus 1, that's bounded because I can put a bound on both sides. The terms never go below 0, they never go above 2. Well, not every bounded sequence is convergent. The sequence a sub n equals minus 1 to the n is divergent. And not every monotone sequence is convergent. The sequence a sub n equals n is monotone, meaning it's always increasing, but that sequence diverges. However, if you have a sequence that's both bounded and monotone, those sequences are convergent. And that's the monotone sequence theorem. It says that every bounded monotone sequence converges. So just as an example, let's see if we can prove that this sequence converges using the monotone convergence theorem. Now we actually already showed that this sequence is decreasing. And it's also clear that as long as n is bigger than or equal to 1, which is all we care about, that this sequence is bounded below by 0 and bounded above by 1. So it is a bounded sequence. So it's decreasing, so that means it's monotone, and it's bounded. And so by the monotone convergence theorem, that sequence converges. Now the monotone convergence theorem doesn't give you any information about what it converges to. You have to do some other work for that. It's just saying that we know it has a limit. We also could have used the function f of x equals 3x over 4x plus 1. We know that that has a limit as x approaches infinity. And so that's an alternative way of answering this question. Okay, that's all for now.